Hello and welcome to another Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler and today we'll be doing Unit 11, Lesson 1 on the purpose of statistics. Now, this is the last unit in Algebra 1 and it probably couldn't be any different than the other units. In fact, it's a little bit weird that it's even in Algebra 1, but we want to continue the development of your understanding of the field of statistics. So let's jump right into it and start talking about the purpose of statistics. Now, we start where you often start in statistics with discussing what kind of questions statistics is most suited to answer. And we call those, not surprisingly, statistical questions. Now, statistics is a branch of math that is very different than most others because it contains tools that help answer questions that involve variability. So there's some questions that involve variability and there's some that don't. You know, when you ask like, well, how many cookies does each friend get, right? You know, I've got 12 cookies, I've got 3 friends, how many does each get? That doesn't involve variability, right? Okay, they each get 4, or what have you, right? But there are many questions, especially in the real world, where the answer to the question actually has to account for variability. Those are the kind of questions that the field of statistics was developed to address. So let's take a look in exercise number 1. Sophia is deciding on her college major and is considering computer science. She would like to explore a career as a phone app developer and is trying to answer the question, how much money do phone app developers make in a year? All right, so this makes a lot of sense, right? You know, some of you in a few years will be thinking hard about going to college and what you might major in college, right? And you might decide you want to major in something that eventually might pay you a decent salary. So, why is this a statistical question? Pause the video now and see if you can write down an answer. Well, it's a statistical question because not all phone app developers make the same amount of money per year, right? There's variability, right? There is variability in how much phone app developers make. And of course, this is a great field to go into because, you know, most people have smartphones and they've got apps left and right and there's new apps coming out all the time, but there's variability, right? One phone app developer might make a certain amount, another phone app developer might make a different amount. If we were somehow living in a country where everyone who worked a given job made exactly the same amount of money, right? I don't know, would that be in a communist country? I'm not even sure where that would be, but if there was such a place, well then it wouldn't be a statistical question anymore. But there's variability, and so therefore, even though it's a very valid question to ask, right, you could see that, right? Like I'm sure that when I was younger, I probably was like, hey, mom and dad, how much does a math teacher make, right? Or how much do teachers make, right? That's a statistical question because not all teachers make the same amount of money. Now, an interesting follow-up question to that one is letter B. What are some of the sources of variability in this scenario? In other words, why don't all phone app developers make the same amount of money? Write down some reasons for why there is variability that affects this question. All right. Well, there are tons of different reasons, right? So let me just write down a few. The first one, which would probably make a lot of sense, would just simply be, let's say, the company a person works for. You know, is the person working for a really large company that's well established? Is the person working for a startup? Maybe the person is their own boss, right? Maybe they're not making any money at all at the beginning. So the company a person works for, that would be one source of variability. How many years they've been working. Oftentimes people that have worked longer make more money. The number of how many years they have worked, right? So you could see somebody who was like, had maybe 10 years of app development experience, getting paid more than somebody who is just beginning. There's lots and lots of reasons. Let's throw one more down. Oh, here's a good one. Where they live. Right? Now that might seem a little bit surprising, but it's not at all, right? There are places like, let's say, New York City and San Francisco, where the cost of living is very, very high. So if a company needs to hire a phone app developer or hire anyone, right, they're going to have to pay that person more than, let's say, if the person was living in Springfield, Illinois, where the cost of living is much lower, right? So there's lots of different reasons that would introduce variability. We could even write down how talented they are, right? Let's say that they are like, really, really talented. Maybe what college they went to. Let's say we got a phone app developer coming out of MIT or Stanford or Caltech or something like that versus, I don't know, Dutchess Community College, right? Now, again, that's not saying that Dutchess Community College is any worse than any of those other ones, but probably you're going to get paid more if you've gone to a really highfalutin school than if you haven't, right? So there's lots of reasons why people might be paid different amounts. Now, to answer statistical questions, we often take a sample from a larger population to examine. We hope to use the statistics from the sample to infer properties about the population from which the sample was taken. Okay, so let's talk a little bit about that in exercise number 2. Sophia decides to narrow her question down to the following. How much money do beginner phone app developers make in a year? So in other words, Sophia is trying to eliminate that one source of variability, which was how long had the person been working on the job, right? And that kind of makes sense because maybe she wants to know, once she graduates from college, how much can she expect to make right away, right? So let's take a look at letter A. Why will Sophia have to work with a sample and not the entire population for this question? Well, this is pretty easy, but pause the video now and see if you can write something down about this. Well, the plain fact is she has to work with a sample because there would be no way to get data from every beginning phone app developer ever. Right? Like there's just no way to do that. She wouldn't be able to get data from every, beginner phone app developer. There's just no way to do that. There's too many of them. They're all over the place, right? Not to mention the fact that they're all over time, right? There are phone app developers from the past, from the future, all of that stuff, and she can't get them all, so she has to use a sample. Let's take a look at letter B. How will the size of the sample that Sophia uses affect her ability to draw conclusions about the population she's interested in? So again, remember, what Sophia would really love to know is she'd like to know this about the population. Like if she could have every beginning phone app developer and know how much money every single one of them made, right, then she could get a real good sense for this. But she can't, which is why she's got to use a sample. But how will the sample size, like how many data points she gets, right, how will that affect her ability to draw conclusions about the population she's interested in? Pause the video now and see if you can write something down about this. Well, it's pretty simple. The larger her sample size is, the more confident that she can draw conclusions based on that sample, right? So the larger the sample size, it's supposed to be the letter Z, and it looks like just a glob of mess. The larger the sample size, the more likely, she can draw valid conclusions, right? And take it to the extreme, right? Let's say that she just kind of went out there and she found 2 or 3 phone app developers and she asked them how much money they make, beginning phone app developers. Well, she could just stumble upon 3 people who are very typical, or she could stumble upon 3 people who make very little money compared to like the population she's caring about, or a lot of money comparing to the population she cares about. So the larger the sample size she takes, the more likely she will draw a correct conclusion about her population. So now let's get into some data. Exercise number 3. Sophia takes a random sample of 20 beginning salaries for phone app developers. The data is shown below in thousands of dollars per year. So again, that 57 represents a starting salary of $57,000 a year, $44,000 per year, $52,000 per year, etc. By the way, these are realistic starting salaries for people who graduate with computer science degrees and go into phone app developing, just for the record. All right. List some statistics that you have learned about in previous grades that would help Sophia start to answer her statistical question from exercise number 2. All right, so I just want you to dig through your memory. You've been studying statistics for actually quite some time now, and you really sort of dug into them in both 6th and 7th grade and a little bit in 8th grade as well. So what I'd like you to do is write down any statistical measures that you worked with that would be able to start to answer her question. Pause the video now. All right, well, there's a ton of them, right? You had things of like measuring central tendency, like the mean, right? Whoops, the meme. The mean, right? That's also known as the average. All right, there was the median. That was the middle number. We're going to talk about all of these eventually. There was the mode. That was the number that happened the most often. There was the range of the data. That was sort of like the high minus the low. There was also something called the interquartile range. All right, we'll be talking about that a little bit as well. Right? So all of these are sort of measurements that tell us something about our data set, and we hope that when we find these things for a sample, that they are also the same or very similar for the population from which that sample was drawn. So let's keep working. All right, finally, let's kind of get into it a little bit. One way to start to answer a statistical question is to give a picture of what a sample data set looks like in a statistical display of data. And there are tons of statistical displays of data, and we're going to be looking at a few of them in this unit. One of the most basics, though, is in exercise number 4. Let's take a look. Sophia would like to visualize how the data from her sample is distributed. Make a dot plot of Sophia's data set. All right, so dot plots are some of the most basic types of graphical displays of data, and they're really nice when you've got some real kind of discrete values. They don't have like a lot of decimals involved or whatever, and it's simple enough, right? 57, I know you've done dot plots before, would be plotted as a little dot above 57, and then 44 would be plotted as a little dot above 44, and if there's more than one of a particular one, you then put that dot above it and above it and above it, and it gives you a visual representation of all of these numbers. So I'd like you to pause the video now and create a dot plot. All right, awesome. So let's take a look. Let's do our dot plot. Here we go. So for 57, I'm going to do this, and then I'm going to cross out the 57. And 44, I'm going to do this, cross out the 54, 52, 49, 53, 50, 54, 55, 58, so far I haven't seen any repeats. 47, oh, there's a repeat. 53, 46, there's another repeat. 52, 46, 42, another repeat here. 53, 50, another 53, another 50, and another 52, right? And again, it just kind of gives us a sense, right? We can see, okay, well, there, it appears to be that there's a little bit more here, a little bit less out here and out here, right? And again, all we're trying to do is build up tools to be able to answer her question, right? To answer Sophia's question about how much money beginning phone app developers make in thousands of dollars. And again, it's nice little graph, right? Gives us a sense for the data distribution. Now, since all statistical questions involve variability, we often want to represent a population or sample using a single number that represents a typical value, or what we call a central value of the data set. Let's take a look at exercise number 5. To help summarize the data in her sample, Sophia would like to calculate the two primary measures of central tendency for the data set, the mean and the median. All right, so we're now going to review mean and median, which you have literally seen for quite a few years. All right, so let's do it. Letter A, how is the mean of the data set calculated? Pause the video now and see if you can write down how the mean of a data set is calculated. It's pretty easy. Pause the video now. Well, it's pretty simple, right? The mean is another word for the average, and what you do is you add up all the data values and divide by how many there are. That's the answer to letter A, right? Add up all the data values and divide by how many there are. Now, what's really great at this level is that with very few exceptions, you don't have to do that anymore. You simply have to put the data into your calculator and ask it to calculate the mean for you. So let's talk about that a little bit. All right, we've never put a data set into our graphing calculator yet. And of course, like always, it's gonna kind of depend on what calculator you're using. Probably more than anything else, statistics really depends on the calculator you use. I'm using the TI Inspire. If you're using a different model of a Texas Instrument calculator or a Casio or whatnot, it's going to be a different procedure. And I apologize for that. There's really nothing I can do about it. I can't show you 5 different methods. I can only show you one. Now on the TI Inspire, what I'm going to do is I'm going to put my data in what's called a list or a spreadsheet. So I'm going to choose this. List or spreadsheet. And then what I'm going to do is very, very carefully, I'm going to start putting these values in, right? And I wish I could have like a little bit more room here. Here, I'll put it over here. So I'll type in 57, then I'll put the down arrow. Then I'll type in 44, I'll hit the down arrow. 52, I'll hit the down arrow, etc. Now, one of the great things about the TI Inspire calculator is it actually allows you to put data into the calculator and then save it. All right, so instead of taking all the time to type this in and possibly make a mistake, I'm just going to actually open up. I'm going to do a file and I'm going to open up a document, and I am going to open up literally Unit 11, Lesson 1, Exercise number 4. I don't care about that. And now I've got all my data in. I even like, you can go up into the column header and you can actually give it a name. I will almost always give it a name, and you'll see sort of later on why that is. So I've called this salary, and then I have entered in all of those 20 data points in here, all right? How about this? Pause the video now and you take a moment to enter the data however you need to in your calculator. Be very careful and check it over once you've entered it. There's nothing your teacher can do if you enter the data wrong, because your calculator is going to ultimately give you your answers. So pause the video now and take a few minutes to enter the data into your calculator. All right, fantastic. We've got the data entered into our calculator, right? And now we want the calculator to actually come up with our mean. So once we have our data in our calculator, I'm going to hit Menu, all right? And there's a bunch of things, insert, data, table, all sorts of stuff. But right down here, statistics. So I'm going to choose statistics. And then it says statistical calculations or stat calculations. That's what I want. And then it's got all these different choices, a few of which we're going to use not today, but in this unit. But I just want what's called one variable statistics. I got one variable, and that's the person's salary. All right. So I'm going to choose one variable statistics. It says the number of lists. I've just got one list. Sometimes I'll have more than one list, but now I just have one list, so I'm going to hit OK. It asks me, what is my list? This is where actually naming it is really helpful, because if I click on that arrow, I can choose my salary list. Frequency list, don't worry about that. The only thing that you might care about now is where you want to put your results. Generally speaking, if you just leave that alone and hit OK, there it is. And it just put all of my results right here. Right here. And we're going to actually go back to this list again and again in the rest of this lesson. But where is the mean? It'd be nice if somewhere in column B it actually used the word mean, but it doesn't. Right here, there's a little X with a line over it, okay? We call this X bar. You'll oftentimes hear your teachers refer to this as X bar, and that is what's known as the sample mean, okay? The sample mean will always be this little X with a line over it, and again, we'll refer to it as X bar in this particular problem. Whoops, oh my. That just went nuts. Let's kind of go back up here, past all this stuff. In this particular problem, X bar is 50.8. So if I added up all of the data and I divided by how many data points there are, I would find 50.8. Now keep in mind, what that says is that it says that the average or mean salary from this data set was 50.8 thousand. Or if you wanted to think about it in terms of like real numbers, it's $50,800 as the average, right? So now, I think we'll just kind of keep it this way for now. Let's take a look at letter C. How is the median of the data set found? So the mean is undoubtedly the gold standard for central tendency. That's the one that you'll hear time and time again. Oh, the average salary, the mean salary, etc. But the median is very important as well. See if you can remember anything about the median. Pause the video now and write something down. All right, well the median, right? The median is the middle number when the data is sorted by size. In other words, if we put the data in order and then we found the number that lied right in the middle, that would be the median, right? A lot of teachers will say, well, you know, when you drive down a road, the dashed line in the middle of the road is called the median. And it is, right? But just like before, the calculator will actually tell us what the median is. And this one, thankfully, they don't label with any magical symbol, right? I'm going to get there. It's right there. There it is, median. It just says it. Median is 52. Now, by the way, your calculator does have the ability to sort a data list into order, but I don't really see much of a point in doing that right here. We can just ask it for the median, and it tells us the median is 52. All right. So the median salary, the salary that's right in the middle, is $52,000. Simple as that. All right, we'll come back to that screen eventually, but let's keep going. All right. Now, although the central values like the mean and the median are very important, and in fact, they're pretty much the first thing you always go to when answering a statistical question, right? Always. You know, it doesn't matter what the statistical question is, you almost always immediately start to think about, well, what is the average blank? Or what is the median blank, right? They don't answer the whole question, no. They really don't. We also want to be able to quantify the amount of variation in a data set, right? So, I mean, statistical questions are all about variation and variability, and we want to be able to also talk about that because, you know, it's great for Sophia to know that the average, salary for beginning phone app developers is $50,800 a year. But if there's this huge amount of variation in the data set, then she very well may be making a lot less or a lot more than that. All right, so let's take a look at exercise number 6. Sophia would like to get a sense for the amount of variation there is in her data. One method for doing this is known as the range of the data set. Fill in each of the following for Sophia's data set. All right, well, so obviously the minimum value is kind of important to know, and the maximum value is important to know, and then we'll talk about the range in just a moment. But let's take a look. So again, what's great about the calculator is it doesn't have to be arranged in order. There is the minimum value. The minimum value is 42, right? Because the calculator can easily figure that out. The maximum value is 58, so let's put those in, 42 and 58. And the range is always defined as the max minus the min, which is equal to 58 minus 42, which is equal to 16. And of course, all of these are in terms of thousands, right? The minimum was $42,000, the maximum was $58,000, so there was a range of $16,000 within our data set. And that's kind of interesting, right? And remember, these are all beginning phone app developers. So the person who got paid the most was making $16,000 a year more than the person who was being paid the least. Now again, that could be because this person was living in San Francisco and this person was living in Springfield, right? Or it could be because this person graduated from a fancy schmancy college and this person didn't, right? Or this person's simply more talented. They got straight A's in college and this person didn't. We don't know what caused the variation, but we do know that there was a range of 16,000, which is quite a bit, right? Let's go back to full screen. All right, so the range is an important measure of variability, no doubt, in a data set. But we often want to know the range of what are called the typical values within a data set, and that's because the range can have what are known as outliers in it. We could have somebody that was hired by a nonprofit and was getting paid $15,000 a year to develop their app, right? Or we could get somebody that was hired, by Bill Gates himself or something, and Bill Gates decided to pay the person $120,000 a year to start. Who knows, right? Those are outliers. Let's take a look at exercise number 7. Sophia knows that the range gives her an idea of how her entire data set is spread out. She is also interested in just how the middle 50% is spread, the most typical values of the data set. For this, she needs to calculate the interquartile range. Fill in each of the following for Sophia's data set. All right, we want to know what the first quartile value is, what the third quartile value is, and what the interquartile range is. Now, the quartiles are literally like knives, along with the median, that slice up the data set into 4 equal-sized sub-data sets, if you will. Again, what's great about our calculator is our calculator will give all of those to us. And in fact, they're right there in a row. The first quartile is 48. The median, which is sometimes referred to as the second quartile, is 52, and the third quartile is 53. So the first quartile is 48, and the third quartile is 53. All right, so let me get those in. 48 and 53. And the interquartile range is very similar to the range. It's going to be their difference, Q3 minus Q1, and that is only 5, right? So much smaller, and it's really quite cool, right? Because if you think about it, right, 48 is right here, and 53 is right here. All right, so all of these data, those represent that middle 50%, right? That's kind of where Sophia can assume she's going to end up landing. The ones down here, they're sort of making less money, right, than the middle 50%. And the ones up here are making more money than that middle 50%. And that middle 50% only ranges by $5,000 per year. Okay, so where does this all leave us? Well, at the end of our analysis, we eventually must loop back and answer the statistical question that was posed using whichever sample statistics are the most appropriate. So again, right, keep in mind how different this is from other math. Think about like a problem like with a parabola, where it's like, hey, the projectile flies in the air given this, quadratic equation. At what time does it hit the ground? We're not like, well, it hits the ground at all these different moments in time. No, it'd be like one answer. But here, when Sophia asks the question, how much do beginning phone app developers make? Because that involves variability, we have to give more of an explanation. And in fact, exercise 8 says, using some of the statistics you have calculated in the previous exercises, make a statement that starts to answer Sophia's question from exercise number 2, right? And so there's a lot of things that we could write down. One thing we could say is we could say, beginning app developers make a mean salary of $50.8 thousand a year and a median of, what was our median? Was it 52? I've already forgotten. Here it is. It was 52, so I didn't forget. Well, I guess I did. Of 52,000 a year. That's a great way to begin our explanation, right? But we might want to throw something else in. Maybe we'll just toss in the range. With a range of 16,000 a year and an interquartile range of 5,000. Per year. Whew. Man, now that's an answer, right? But that is statistics, right? Statistics is unlike any other branch of math. Most other branches of math, when there's a question, there's sort of one answer. Now, how you get that answer, there might be multiple pathways to get there, right? But statistics, right? How much do phone app developers make at the beginning of their careers? Well, again, it depends. And it depends on a lot of different things, right? But if all we want to know is the answer to that question, right? We go out, we take a sample, and we found in that sample that there was a mean of $50.8 thousand a year and a median of $52,000 a year. We saw there was a range of 16,000 a year and an interquartile range of 5,000 a year. And that gives Sophia a lot of information, right? She knows, oh, okay, if I go out there, I should be able to expect a starting salary around that. But of course, given this range, I could have a salary that's quite a bit lower than these two or quite a bit higher than these two. But if I'm in that middle 50%, then I'm not going to have much of a range at all. Okay? So, what is the purpose of statistics, right? The purpose of statistics is to answer questions that definitely have numerical answers to them, but answer questions that have variability that affects the answer itself. Given that there's variability, we then develop these tools like measures of central tendency, the mean and the median being the two big ones, and measures of variation, the ones that you know right now are the range and the interquartile range. We develop these to try to be able to answer the question without being able to give like one specific number. Now, when one specific number is given, it often is the mean or the median. But that still really doesn't answer the whole question, given that there's variation in the data set. So throughout this unit, what we're going to be doing is developing more tools to answer these statistical questions, and we'll see that throughout the unit. For now, I just want to thank you for joining me for another Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler, and until I see you again, keep thinking and keep solving problems.